Welcome again, and as always, thank you for joining to watch this optional video. So we just got 5 slides that we need to get through. This should go pretty quick. Find the zeros of f of x equals x cubed minus x squared minus 2x. So if I'm finding the zeros, what I want to do is factor this so that I can set each one of those factors equal to 0. So looking at this, the first thing I see is I can take out an x. When I greatest common factor an x out of this, I get x squared minus x minus 2. After that, this is trinomial factorable. So I'm going to bring down this x, and then I'm going to set up my two binomials. Looking at this, the only two things that multiply to x squared are x, and numbers that multiply to -2 and add up to -1 would be -2 and +1. What I do with each one of these then is say, okay, this whole thing is supposed to be equal to 0, because I'm looking for zeros, and I set each of these equal to 0. So I get x equals 0, x equals 2, and x equals -1. Graphically then, the way that this graph looks, I have a 0 at -1, a 0 at 0, and a 0 at 2. And what our graph looks like is this cubic function that passes through those 3 points. Be comfortable coming up with a sketch of this based off of these equations, or based off of these factors, and finding those zeros. What are the zeros of f of x equals x squared times x minus 2 times x plus 1? So it's already factored, which is great. If I want to now talk about the zeros of this, what I have to do is just set each of these things equal to 0. So if I set this equal to 0, I get x equals 0, I get x equals 2, and I get x equals -1. We have some other information that we can keep in mind, like for instance, the degree. If I want to talk about the degree of this overall polynomial, right now it's written as factors. So you have to ask yourself, well, if I were to multiply this out, and you don't multiply it out, if I were to multiply it out, I'd have x squared times x again. So the degree is going to be 4. 2 plus 1 plus 1. The lead coefficient, we just care about, is it positive or is it negative? Well, this has a positive x squared, a positive x, and a positive x, so it's going to be a positive coefficient. Now, what does this tell me? Okay, well, a degree of 4 means I have something that basically looks like a parabola, and the lead coefficient being positive is that it hasn't flipped over. So now if I want to sketch this, I'll draw myself a little sketch. I have a 0 at 0, at 2, and at -1. However, this 0, there's something unique about that 0, and that is the exponent. Here, this factor has a degree of 1, this factor has a degree of 1. This factor has a degree of 2, which means that this is really a double 0 at x equaling 0. Remember, there's something unique about that. So things that have an odd degree, we pass straight through them. So if I'm sketching this graph, notice it's supposed to rise on both sides. So I'm going to start here. I'm allowed to pass through this, and I sort of missed it, so I'm just going to start over. Don't worry, I'm not changing anything, just my art skills. I am allowed to pass through that. And now when I come back to this 0, it's a double 0, which means I'm just going to not pass through, but slightly touch right at 0 and then come back down. Then at 2, I have a single 0, so I'm allowed again to pass through that. Now, if you're sitting there and you're like, well, mine looks a little bit different, like mine looks more like a total W, that's totally fine. We don't know how far down these minimums go. I intentionally wanted to do something a little bit offset to show you that it doesn't have to be like that. It could be like that for all we know. We're just trying to get down the idea of how these zeros affect that sketch and how multiplicity affects it. All right, so moving along. What are the zeros of f of x equals negative x cubed plus 8x squared minus 12x? So first, looking at the degree here is the highest degree, so that's 3. Looking at the lead coefficient, our lead coefficient here is negative, which tells me that there's going to be some reflecting going on. So if I want to look at this in factor, I can see that each term has an x, and I'm also going to pull out the negative because what that will allow me to do then, if I knew how to factor, is have a positive x squared here. So now I'm going to be able to type 1 factor this, or trinomial factor it. So I'll have x, and I want numbers that multiply to 12 and add up to negative 8, which are negative 6 and negative 2. I set each one of these factors now, and I'll switch the color for emphasis. I set each one of these factors equal to 0, so I get x equals 6, x equals 2, and x equals still 0. And if I want to sketch a graph, the degree is 3, it's negative. So usually, and this is why you have to know your basic functions, usually something with a degree of 3 looks like that. Degree 3, positive. Degree 3 negative is just going to be a reflection of this. So it goes like this. It's going to rise to the left, fall to the right. So I'll plot my zeros. 0, 2, 6. Keeping in mind the idea of this graph, I have to start up here, coming down, keeping in mind the idea of multiplicity. These are all to degree 1. So I'll cross through each one of these zeros and make that sort of S shape. Again, these mins or maxes might go higher, but what we do know is these points, these 3 x-intercepts, and how we cross through them or just skim across them. All right, we can sort of change these questions. Write the equation of a polynomial with zeros of 1 and negative 2. So I'd have f of x equals, the zeros are going to be 1 and negative 2. So I'm going to have x minus 1, because 1 would zero out this equation, and x plus 2, because negative 2 would zero out this equation, or this factor. If I want to sketch the graph of this, for 1, looking at this, the overall degree is going to be 2. The lead coefficient is going to be positive. You could have actually made it negative if you wanted to get fancy, but it didn't tell us anything to make us do that. So we have a 0 at 1 and a 0 at negative 2. We could be a little bit more specific. So if I multiply this out, I get x squared plus x minus 2. And if I wanted to know the y-intercept of this graph, sort of just doing something a little bit extra here. If I wanted to know our y-intercept, that means I'm substituting 0 in for x, and that would give me negative 2. So I do know another point on this. I know my y-intercept is negative 2. That doesn't mean it's a minimum. It could be, but we don't know that. All we know is that it's, I crossed through the y-axis at that point. So if I want to draw a little sketch of this now, degree is 2. It's positive, so it's just a regular parabola, which makes me know that this is not the minimum. Can't be, because there's supposed to be symmetry in a parabola. And this is over 2, this is over 1, so somewhere right around here is where I'm going to have my axis of symmetry. But, we just care right now about those zeros, y-intercept, lead term, degree. All right, let's do another one. Write the equation of a polynomial with zeros 0, 0, 2, and negative 4. Notice this 0, 0 is telling me that there's a double 0. which is telling me the degree of the factor. So I'll do the easier ones first. 2 means we have x minus 2, because that would zero this out. Negative 4 means I have x plus 4, since that would zero this out. The thing that would zero out 0 is to just have x. If I put 0 in for x, it zeroes out this factor and the whole equation then. Because it's a double zero, it has to be an x squared. So I have f of x equals x squared times x minus 2 times x plus 4. While not particularly required, I'm just going to multiply it out for fun just to show you. I get x squared, good skill building. If I multiply this, I do x times x, which is x squared. Negative 2 times x and 4 times x. So negative 2 times x gives me negative 2 and positive 4. When I combine those, I get a positive 2. And then negative 2 times 4 is negative 8. Distribute my x squared, so this is x to the fourth plus 2x cubed minus 8x squared. Our degree here is 4. You could see that here, or you could see it from the 2 plus 1 plus 1. Our lead coefficient is positive because we got to make it whatever we wanted, so we made it positive. And if I'm going to sketch a graph of this now, y-intercept, by the way, if I put 0 in here, if you wanted, f of 0 is going to be 0. No y-intercept. Could have made one, chose not to. So I know that at 2 and negative 4, 1, 2, 1, 2, 3, 4, I have zeros, and then I have a double zero at 0. Degree of 4, leading coefficient positive, means I have some parabola or parabola-looking thing. Where the 0, I do not cross through. So I have to fall right here, or I have to decrease right here, cross through that point, come up to 0, not cross through it because it's a multiplicity of 2, come back down and go back up. And that would be a little bit smoother. So I got that W looking shape again. All right, that's all we have to talk about. Get some practice with that. It's not too bad, and I'll usually let you know when things are pretty tough. This isn't really that tough. You can all do it.